In this video, we're going to begin our section on integers by looking at absolute value. So if you look in the South Carolina State Standards, 6th grade is officially the first time when our students start learning about positive and negative numbers. All through elementary school, they focus on positives, and then in 6th grade, they're going to go back and do many of the same operations and skills that they did in elementary school with positive numbers, now with integers, now with positive and negative numbers. And then we're going to extend that to rational numbers, which would mean positives and negatives not only of integers, but also fractions and decimals. So you'll notice that finding absolute value becomes important starting in 6th grade. Please note that in 6th grade, our students are not doing anything with the positive and negative numbers. They're just learning how to find them on a number line. They're learning what they are, what things represent negative ideas, and what things represent positive ideas. Now in 7th grade, that changes. 7th grade is when we start looking at adding and subtracting rational numbers. And you'll notice that absolute value comes up again because distance is the absolute value of the difference between the two numbers. So we're going to be adding and subtracting. You can see absolute value here again. And then also in 7th grade, we're going to be multiplying and dividing our integers. So we're going to learn all of our positive and negative rules. But in order for these to make sense, we have to start off with the idea of absolute value. So absolute value, by definition, is the distance on the number line from 0 to the number that we're looking at. So what often happens is that people misunderstand what absolute value does or what absolute value is. So absolute value is a measurement. It is a distance from 0 to the number that we have in question. So for example, absolute value of 4. That is really asking you how far away is the number 4 from 0. Well, if you measure, you can see that it's 4 units away, so that absolute value is going to be 4. The same thing with negative 4. If you ask this question, what you're really asking is how far is negative 4 from 0? What is that distance measurement? And if you look right here, the measurement to that is also 4. So absolute value is going to be positive because it measures a distance, or it's going to be 0 because 0 is 0 units away from itself. So my only two choices here are positive or 0. Absolute value will never give me a negative answer. Sometimes what our students misunderstand is that what absolute value is something that makes everything positive. And that's not true. What absolute value is a measurement, it is a distance, and therefore it becomes positive. So it's kind of a consequence of the fact that absolute value is a measurement, that absolute value also happens to make things positive. Another mistake that our students sometimes make is they think absolute value makes it the opposite of whatever it is. So the absolute value of negative 4 is 4, and some of them will misunderstand and say the absolute value of 4 is negative 4. Again, this comes back to a misunderstanding of the definition of absolute value. If we understand that absolute value is measuring a distance, then it makes sense why absolute value would always give us a positive answer and why a negative answer doesn't make sense. You can't have a negative 3 feet. That negative would tell you a direction. The 3 feet would be the distance. Okay, so here's the actual absolute value definition mathematically. The absolute value of x equals x if x is greater than or equal to 0, and the absolute value of x equals negative x if x is less than 0. Well, hang on a second. We just said that absolute value has the effect of making everything positive. So why do I now have this negative x in here? Isn't that the opposite of what I just said? Okay, well look at the way x is defined. Do you see that in this line, x is defined to be less than 0? X is a negative number. So if I have the absolute value of negative 4 like I had on the other screen, that is the opposite of negative 4, which is going to give me a positive 4. So this negative right here is saying I'm going to do the opposite of a negative, which is a positive. On the top line, x is greater than or equal to 0, x is already non-negative, so therefore it is just itself. I don't need to change it from what it was before because it is already non-negative. In this case, the x value itself is negative, so I need to take the opposite of it to become something positive. So mathematically, this is what the definition of absolute value looks like. Okay, so now let's take that idea and evaluate each of these 5 things. Okay, so pause the video here, evaluate each of these 5 things. Let's see what we get. Okay, for A, absolute value of 20. Absolute value measures a distance, and 20 is 20 units away from 0. So the answer to that is 20. All right, absolute value of -5. Again, absolute value is measuring a distance. How far from 0 is -5? It's 5 units away. So the answer to that one will be 5. All right, absolute value of 0. How far is 0 from itself? Well, it is itself. It is no units away from itself. So the absolute value of 0 will be 0. Okay, look at this next one. This one could be a little bit tricky. Think about the absolute value working like in an order of operations sort of sense and look inside the absolute value. What is the absolute value of -3? Well, -3 is 3 units away from 0. So the absolute value of -3 is 3. And then that negative on the outside just comes over. So the answer to the opposite of the absolute value of -3 is -3 because the absolute value itself was positive and then that negative just comes over. All right, this next one is a little bit different. Again, think about the absolute values in sort of an order of operations way. And 2 plus -5 is -3. And then the absolute value of -3 is 3. -3 is 3 units away from 0. What you do not want to do here is think about this in your head like this. You can't quote unquote distribute an absolute value. 2 plus 5 would be 7, but this question and question E are not the same thing. This question has the absolute value on each of the numbers and then we're going to add them. This question says I want to add the numbers and then take the absolute value of the sum that I get. Okay, so if we think about integers, representing integers on, say, a number line, we have the negative integers on the left and the positive integers on the right. And we would say that the negative integers are the opposites of the positive integers. So -4 is the opposite of +4. And if we say that the opposite way, +3 is the opposite of -3. It doesn't matter which one goes first or second. The negative is the opposite of the positive. It is also true that the positive is the opposite of the negative. Could go either way on that. Okay, one thing to note here, your book chooses to use an italicized I to stand for integers. That is not standard notation. That's just something that your book is going to do. So if you step outside of this particular textbook and maybe you pick up a different textbook or you look at the text that your school is using, you may see a Z. Integers are more frequently denoted by Z than by I. So just be aware of that. If you look other places and you see a Z, that is the more official way of representing integers. Just your particular book is going to use I. Okay, so in each of the following, let's see if we can find the opposite of x. Okay, pause the video, see if you can find the opposite of each one. All right, let's see how we did. So the opposite of x here is going to be the opposite of 3, which is -3. In B, the opposite of x is going to be the opposite of -5, and the opposite of -5 is +5. So the opposite of x here is +5. And then on the last one, the opposite of x, well, 0 is not really positive or negative. That doesn't actually make sense. What you want to just say is the opposite of x is still 0. 0 is neutral. It's right there in the center. Everything to the right of 0 is positive, everything to the left of 0 is negative, but 0 itself is like the changing spot. It's the division line between the positives and the negatives. And so it is itself neither positive nor negative. It's just right there on the border. Sorry, my computer just did the wrong thing.